Okay, thank you for staying with us through this workshop, because we realize it's not on everyone's topic, but we still hope you learn a lot about what we're doing. And you've seen, and also in the last presentation, that this session is a cooperation. It's an establishment of cooperation between Blue Cloud and FAIR East. And also about the topic that I'm now touching on, and well, it could have fitted anywhere, I think, in this schedule. It's about data discovery and access. This is also a shared topic between the two. You can see it as Blue Cloud being with a focus on the marine environment already established. Blue Cloud's already ongoing now for more than 4 years, because it's now in the next iteration, while FAIR East is new, and FAIR East is working on innovation. And that's also the purpose here for the data discovery and access. We're working on new conceptual designs about the virtual data lake. I like your presentation a lot. It was really clear, thanks. So I can skip a lot. And my name is actually Peter Thijsse. I should pronounce it Thijsse. Yeah, it's unpronounceable by anyone, but it doesn't matter. I work for Maris, and we're actually involved in both projects, and we're leading, coordinating the work on the data discovery and access in both projects. Yeah, let me just immediately dive in, because you've seen that we are speaking about Earth Analytical Labs, virtual research environment, whatever you name it, and we're data hungry in those labs. We need to have access easily to the data, and that's a big challenge here. As it was presented by you very clearly, how do you find the data, exactly the data that you want, and how can you easily access it? It's all about fair data, fair software, and yeah, I think in the end we come to something called fair services. And the challenge is that there's many different data providers out there. Some we know, and those at least you cooperate with. So with those you can set up a cooperation. Some you don't even know. You might want to relate into them later, and that's, I think, when you speak about the data lake. If everybody would follow certain rules for the services, for their data, yeah, then you getting close to a data lake. And actually, then you also come a lot closer to the European Open Science Cloud, but that's another. It's very important that we're not only speaking about human data discovery, because everyone can Google as a human, but we're speaking here about machine users and people behind the machines that want to access data. Yeah, whatever we call it, data lake, space, workspace, it's all good for me. What is important, and that's the current status. This is an example of Blue Cloud, where we have a data discovery and access. It's not, as Marciana said, it may not be the data lake yet, but it's at least a mean that we can browse there through various connected blue data infrastructures, as we call them. You can browse on the metadata, you can find them on the map where they are, you can select the parameters that you want, and in the end you find data sets and you can actually push them into your data pool in the VRE. What is the next step is that in this case you still get complete files. So if you search for temperature, it might be that in those files that you ordered, which are huge, or you've searched in such an area, could be there's data for many more parameters and in a much larger area. And that's not what you want, because you still need to subset them first. So we solved part of it, and we're planning on solving other parts as well. So what we've done so far, and forget about this very complex slide, just focus on this part, is that we have several blue data infrastructures, and in the marine domain we have something called EMODnet, I don't know if you're aware of it. We have research infrastructures that do research on all kinds of topics, that have near real-time data, biological data, and at the moment we've connected in Blue Cloud to each of these infrastructures because they're in the project, and we created some kind of brokerage to get to their service and to be able to look up from the metadata the data files, and then be able with the machine to draw them in. So that's at least the first step. In FAIR East, because you will see I have them side by side here sometimes, We're planning to go a step further. We are not only looking at the blue data infrastructures, but way beyond, as you saw in the presentations. And there we really need to go into this cloud mechanism, and also, important, we do not have these infrastructures on board. But at least we can work on innovative solutions, how you can then, as the data providers that we see, how you can then go from just the metadata search and then getting access to the files, how could they improve their services in exposing such data fragment metadata, as I always call it, as Katrina mentioned it, how could they work at so that it in the end becomes a list of sets that I can access and I can choose as a user, I want the full set, or no, I just want this subset, but even that subset has its little descriptor of what it contains. Then we're getting there. Yeah, I think I will skip this one because it's a bit about how we foresee then this assets, as we call them, these little data fragments, how we think we can make use of it. But what is important is that if you look at Blue Cloud, we have this solution of metadata search and brokering, and that you can access these whole files. But we do know that we need, if you want to really support the virtual research environments at its best and the users, that also there are subsetting services out there that can directly feed you the subsets that you want. And also we could look into how you could create subset out of these. Or if you've drawn them in, can you maybe cache that data and set a subsetter on top of that? Because it's an interim solution, because in the end you're hoping that everyone has a kind of a subsetting service, but yeah, that's not the case yet. Yeah, so there's really similar challenges here between Blue Cloud and FAIR East, and actually there's other initiatives as well that run into the same issues. We're highly dependent on this FAIR data, because it needs to be findable, accessible, and that the metadata should be so well that you can reuse it, and also in the data itself that, for example, in the data files, that everybody uses the same terminology, or at least vocabularies, for which parameter, which variable is measured. If I'm speaking about temperature, does the other one use the same temperature with the same type of sensor, for example? Otherwise you cannot combine it. FAIR software, so all the software that you use for processing, if you take it from somewhere, is it published also with the right metadata? And then I go to the next one, because if this data lake will consist in the end of a distributed network of data access services, and they expose their fragments, but how do you know, as a machine, how to then access this little data set behind that fragment? Then the service itself needs also to be, well, call it FAIR. It needs to be findable, accessible. Okay, you found it because it's in the fragment. But do you know how you can call it? What's the expected input that it wants as a parameter? What's the output that you get? Well, really important parts, and that's not covered yet. And actually, in a discussion I had last week with somebody from the EOSC interoperability framework, that came also on the table. It's a really missing part there. And there is an interoperability framework, well, but it's not really not to this level yet. And I think for the success of EOSC, it would be great if we could have this. Yeah, if we want. And there was a nice speech last week about that it was an orchestra. I heard from you that EOSC should be an orchestra following the same rules. Well, this is one of the rules that we still have to set up. How do you define your services? Yeah, this is just a comparison between Blue Cloud, how it works now from metadata to the data access and to order it while we want to, but that we need a specific conversion for every service. And that it's a human interaction so far to set that up. And for FAIR East, we want to go beyond that. And then feed that kind of solutions also to Blue Cloud and other community. So yeah, as I said, fair data is important. If you want to work in a way with fair data, there are metrics that you can confirm to, see if you publish the data according to the rules. The same is now for fair software, just a little bit different because it's also kind of a research object. But then we are setting up now a working group in Fair Ease on how can you describe well this kind of a service, accessible for machines, what the service does, how it works, how to access it. So both for processing as well as for data access. And there are things that are already existing. We know. Probably doesn't ring a bell for many of you, but there's all kinds of documentations already, but they don't have what is exactly needed. But we won't start from scratch. We will look, I mean, the open API, that's really important, is an important standard, but it's not quite there yet. So we will look for the best possible ways and then expand it, and then not do it on our island, but hopefully in communication with others. And that's also the question that I put on the table. Well, if I would have had an audience of 300, then probably there might have been some people working on it, because the question is, of course, are there in other domains, disciplines, are there also, do you know of working groups that are already working on it? And if so, yeah, we're happy to share this, our views and exchange the proceedings that we will get in our work. Anyway, we will feed the outcomes of this work into the working groups where we are already involved, and also into EOS, and well, we'll demonstrate it in small scale in Fair Ease, hopefully then in a larger scale in Blue Cloud. And then, since we know that Blue Cloud is very well on the radar of EOS, then hopefully this will feed also into the other interoperability initiatives. Thank you.